Hey everyone! In this video, we're going to look at how we can rewrite in vertex form again. So yesterday in class, we talked about how we would rewrite into vertex form with completing the square. So let's revisit that in the do now here. So to complete the square, first thing we want to do is isolate those x squareds and the 18x by itself. So in order for us to do that, we're going to subtract 11 from both sides first. Now you can rewrite f of x as y if you prefer to. If the f of x doesn't bother, you can leave it alone. But we're going to have f of x minus 11 equal to x squared minus 18x. Now, I left that space there on purpose. Because remember, the way I like to do it is I like to add a square to both sides. Because we are using the completing the square method to rewrite it in vertex equation. So that part helps me remember to myself that I want to make sure to add something to both sides. So when I'm looking at that, now my next step is how do I fill that square? So I take the term in front of the x that's by itself, so this negative 18. And I'm going to divide that by a 2, since there's two squares we want to fill. And I square it because we're filling squares. So we know that that's going to be negative 9 squared, which gets us 81. 81 is what I fill both of those squares with. Now, on the right side of this equation, our goal is to factor. Now, you can factor it out in pieces. Like I'm thinking about that AM method. So I'm thinking that two numbers that multiply to 81, that would add up to a negative 18. But the other part of it is reminding yourselves that we want a perfect square trinomial here. So if we set this little up here, this negative 9 is going to fit that bill perfectly. Because we know x minus 9 times x minus 9 is going to be what we're looking for. But really, we just want to be able to rewrite that as x minus 9 squared. So you don't have to write out that middle piece if you remember that. But then on the other side, on the left side of my equation, I'm going to take that f of x, and I'm going to combine the like terms. So I've got a negative 11 and an 81. So when we combine those, we're looking at 70. And now the last step for us to get in vertex form is to bring that number back over. So my final answer over here in vertex form, f of x will be equal to x minus 9 squared minus 70. Now, that's important for us because we should remember that the vertex form is in the form of f of x equals x minus h squared plus k, where h is your horizontal shift. So h is my horizontal shift. It tells me if it goes left or right. If it's a minus sign, we know we're going to the right. So that also tells me that my vertex starts off with a positive 9. So remember, we switched that sign. We're just pulling that 9 right out. And my k is the vertical shift, so whether it goes up or down. And that's just going to be a negative 70. Well, that might not be the nicest thing for us to plot on a graph. That's still the vertex nonetheless. Now, to describe that transformation from the parent function, like I was just saying, h represents whether you're going left or right. Left is going to be if there's a plus sign. Right is if there's a minus. So we know that I'm going right 9 units compared to that parent function of x squared. In that same thought process, we have k is whether it goes down or up. Now, when it's outside of those parentheses, we just stay true. So we have minus and plus there. So it was a negative. So we're going down 70 units compared to the parent function. And that would be good. So we get that. The reason we rewrite in vertex form is so that we can identify what exactly the shift was that would take place, what transformations occur. And we can identify that vertex. Now, what we didn't tackle yet is what happens if there's a number other than 1 as a. So remember, if you're thinking back to standard form for just one moment, we talked about this in class yesterday. Standard form is equal to y equals ax squared plus bx plus c, where a, b, and c are all numbers. But yesterday, we strictly did vertex form as if a was 1. This time, we're going to deal with it when it's not. Now, we're going to start off the same way. So when I rewrite this and I start this off, my first move is going to be to minus the 5 from both sides. So I'm going to be dealing with an f of x minus 5 equal to a 2x squared minus 4x. Now, notice what it says. It says factor that leading coefficient out. So in here, I can factor out to rewrite this as x squared. Now, if I factor out the 2 from both pieces, I'll be left with a 2x. Now, I'm still going to leave some space because I still want to be able to complete the square. Now, keep in mind, when I rewrite the other side, whatever I factor that out with, I'm still going to want to add on my square to both sides, but I factored out a 2. So essentially, it's like whatever that square is, it's times 2. So I'm going to make sure that that 2 is in front here. Because whatever I add to one side, I have to add to the other 2. So I'm keeping that consistent as I move forward. So far, I factored out my leading coefficient. I'm going to complete the square using the same thing we've been using like we saw in the previous one. We're going to take our b term divided by 2 and we're going to square it. So b now is whatever's in front here. So we're not using that 4 from before because that's why we factored it. So over on the side here, I can take that negative 2 divided by 2 squared. It's going to be negative 1 squared, which is the same as 1. So I'm filling a 1 into both of these squares. Now everything else is going to be business as usual, right? So I'm going to combine on here. I'm going to have f of x. I have negative 5 plus 2 times 1. 2 times 1 we know is 2. So now I have negative 5 plus 2, so we have a negative 3 on that left side. Now I can go ahead and factor on the right side. Now when I go to factor, well, there's only one combination of numbers that I know that multiplies to a positive 1, and it adds up to a negative 2. So remember, that matches what's over in here. I could write it as x minus 1 twice, but really the whole point of me doing this is so that I have x minus 1 squared. Now I'm going to bring everything else down with it. So we have our f of x minus 3 from the left equal to the 2 in front there. Only thing left for us to do is to add 3 to both sides. Now, bear with me. I'm just going to shrink this 1 second so I can fit my last line on the bottom there. So my final answer, f of x is equal to 2 parentheses x minus 1 squared plus 3. Now, I've still done a transformation, right? I still know my vertex is now at 1, 3. So I can figure out what my vertex is. We get that from here. So vertex 1, 3. Now the 2 out in front does have an impact. It is going to change the transformation a little bit. It's going to be a stretch or a shrink. In this case, it's going to be shrinking it down a little bit, but we'll talk more about that later. For now, I just want to be able to identify the vertex and rewrite. So I'm going to do one more with us here. Now, when I put this one more up there, let's look at what we're going to do. We're going to repeat and do the same thing we just did. So that being said, my first move is to get the number without an x back to the other side, right? So I'm moving this over. I have f of x minus 5. I'm going to leave a space, a little bit more space there. And I've got 3x squared plus 12x. So now I can't go about my normal business until I can account for that 3 out in front. So 3, then I'll have x squared plus 4x plus some number when I go to fill that square, right? On the other side here, I'm going to have f of x minus 5 plus, remember, I'm taking whatever number's in front, that 3 is going to go in front of the square because you're technically going to be multiplying, so we don't want to forget about it in that step, so we add that to both sides. Now we're ready to complete the square. We can say that 4 that's there Remember, we're looking at 4 divided by 2 squared, which is going to be 2 squared, which is going to bring us back to 4. And that's how we fill this box now. So when I think about the factoring part of this parenthesis is just going to be x plus 2 squared. Remember, I'm thinking a number that adds to 4 but multiplies to 4. So you're multiplying to 4, only the 4, 1 and 2 and 2. The one that adds to 2 is there. I'm going to bring down this 3. I'm going to look at the left side. F of x is equal to. So now I have 3 times 4, right, which is 12. We're going to combine our like terms. So f of x plus 7 is equal to a 3 times x plus 2 squared. My last step is to subtract that 7. So now we'll be written in vertex form. We've got the 3 in front of the parentheses. Inside is x plus 2 squared, and outside is minus 7. And we rewrote it in vertex form. We are happy with our results. The only thing left to remind ourselves is that the vertex, inside the parentheses, we switch the sign. So it's going to be a negative 2. And outside, we keep the same, so negative 7. Okay, so you have 3 more questions to try today. 2, 3, 4. I'm going to put the answer key up so you can compare your answers. But those are right now the ones that we were looking at. I am going to skip ahead here just to give a little recap of the different types of transformations we worked with so far. So as I look here, reminder, x squared is going to be like the parent function. So when I'm thinking about x squared, we could think of these dots here, right? 1 squared is 1, negative 1 squared, 2 squared is 4, negative 2 squared is also 4. But your parent function here is a parabola. It gets that basic shape along the way. I guess I could try to hit a little bit more of my points. X to the third is a cubic function. 0 cubed is still 0. 1 cubed is still 1. Negative 1 cubed is a negative 1. But be in mind, 2 cubed is going to be up at 8. So it's somewhere up here. So you're thinking that kind of curved piece, same way as we're going to make a curved piece along the way of that. So that's what our cubic function looks like. Remember, in square roots, we don't want any negatives. So we're starting at 0. 0, square root of 0 is 0. Square root of 1 is 1. Square root of 2 is a decimal. Square root of 3 is a decimal. But square root of 4 is at 2. It's going to follow that pattern there. It looks something roughly like this. And absolute value, remember, that's our harsh V there. So if I plugged in 0, here's 0 units away from 0. 1 and negative 1 are both going to be positive, so those are magnitude bars. 2 and negative 2 will both be up at 2. It follows that pattern, so that's what your absolute value would look like. Each of these are known as the parent functions. They are the most basic versions of themselves. So being the most basic version of themselves, this is what we're looking at. This is what we're dealing with. So each other type we can play around with. Just so you have a list to compare to here. When I have x squared, the transformation is going to look like a x minus h squared plus k, which is what we did all our rewriting as just now. H, again, is your horizontal shift, k is your vertical, and we would use that. For the parent function of the cubic function, I'll switch it over to functions here. Same thing, a, x minus h. Now I'm going to do cubed plus k. For the transformation of a square root, a square root of x minus h plus k on the outside. Last one, f of x equals a x minus h plus k. So they all follow the same trend. All of these ones are going to have an a value of 1, so we don't have to worry about filling in an a for any of them. We just want to talk about the shift. So if I look at this first one, it's quadratic. So I know it should look like y equals a x minus h squared plus k. Since we know that a is 1, we're not worried about it. You can put in a 1 there. But I'm just looking for what this shift is. So x minus, so if I look, this is my vertex. This is my turning point. It happens at -5. Oops, sorry. That was my y value. It happens at 3, -5, which makes sense because if I count over, I'm going 1, 2, 3 units from the original origin, right? Down 5. So -3. Minus k. So that's what something like that would look like. Here, because we see the reflection occur, when I go to write this, y equals, I automatically am going to start off with a negative. I know it's negative. I can start that piece up there. I could do x again, but this time, if I look here, my vertex is now at -5, -2. So since I'm going to the left 5, we're going to have a +5 in the parentheses. It's still the quadratic shape, so it still gets a squared. And then the shift is down, so -2. That's what we're looking at here. So each one we're just going to rewrite. So for 3, it started at 0, 0. My my square root here is now at a point that's starting at 7, -5. So now this function is going to be y equals, again, we're leaving a alone, x minus h, because we're going to the right. I didn't need as big of a piece here, plus k. So y is equal to, in this one, x minus 7 minus 5. And you can always double check. You can plug that into a graphing calculator just to see if that's what works out. Cubically, right, if we have this, here's my point where it's that middle. That's where the origin originally was. So now it's at -4, -1. So like we said, that was a we're not worried about for the purpose of this, but it's to the third power plus k. This time around, we're going to have x plus 4 cubed minus 1. Okay, so the other thing I want you to try is these couple here. Absolute value works the same way. So I'm leaving you with 4 questions here that are quick, 3 questions of practice. I'll put up an answer key for you to check, but then we'll come back and regroup, and you guys can let me know if you have any questions with that when I'm with you again. All right. Have a great day, and good luck when you're trying this, guys. Thank you.